after renovation, the building in the Czech Republic, before and after. Again, in the case of the Czech Republic, we have used wood facades compatible with the local production and the local climate, and the building in Athens, whose facade could not be modified because it's a building that it's preserved by the municipality. We have achieved significant energy savings. You can see here a comparison between the pre-renovated and the post-renovated state. I don't want to go into detail because my colleagues will present them in short. What are our main achievements? We have demonstrated that we can manufacture fully prefabricated, industrialized, plug-and-play facade solutions that can achieve net energy operation of the building after renovation. And not only this, by dimensioning properly the technical system, the renewable energy sources, we can even make them positive energy building and contribute to the overall concepts of energy positive districts, of handling the renewable energy at the municipality or at a regional level. The successful implementation in the prefabrication of renewable energy sources, such as PVs, organic PVs, solar thermal systems, heat pump, fan coils, ventilation units, air handling units, hydronic systems, has been demonstrated. And this is quite a broad range of technologies that we have managed to demonstrate that it is compatible with this type of industrialized, lightweight, prefabricated facades. We demonstrated that we have considerable savings in terms of installation times and costs. The potentials of our technologies are significant. We can include, for instance, thermal storage in the prefabrication. We can include EV charging for electrical vehicles in the prefabrication. So this type of technologies can also look in the future. What are the next steps that we have to do? We realized during the course of the project that for each system, you need to take into account the characteristics of the building that has to be renovated, deeply renovated. So I use the term performance-based building design. So the architect has to work very closely with the manufacturer to make the design, the renovation design, taking into account the specific capacities and the specific technical characteristics of the facade. So in this process, the manufacturer comes closer with the architect, the developer, the owner of the building. It is a new way of thinking, a little bit different from the current approach where the architect has a database of ready-made solutions, and he selects the one that he or she believes that it is more appropriate for the building that needs to be renovated. Now we can adapt the solution to the requirements of the building, and the collaboration is very much needed. The use of digital tools like building information modeling have the potential to speed up the process of designing solutions for deep renovation, to better control and monitor the renovation process and reduce overlaps and mistakes. Technologies like 3D laser scanning of the building before the renovation process can effectively help the architect, the designer, the developer to minimize potential errors, because you don't really know, especially if you have an old building, what is the status of the building at the pre-renovation state. If we select materials that are nature-based, recyclable, renewable, we can even go one step further to achieve zero-emission buildings. And this is a potential that this type of technologies can offer for the stakeholders of the sector in the future. So this was a very brief, I hope, it was supposed to be 10 minutes. I know I talked for much longer, but I hope it was a good overview of what were our targets, our scope, and what we achieved in the frame of this project. Thank you very much for the attention. I don't know if you have any questions that you would like to ask me. If not, we will proceed with the presentation of the 3 core technologies of the Plural project. And I would like to ask Mr. Tsoutis, the owner of Advanced Management Solution, to come and... oh, no, sorry. I forgot. We have to show the video. I'm sorry. So, to give you a better overview of the... It's a very short video.
Reduction of energy consumption and emissions in buildings is vital in meeting the EU's climate and energy targets for 2030. In particular, the residential sector represents approximately 27% of the final energy consumption. Given that 85% of the building stock was built before 1990, it is evident that improving the energy performance of buildings calls for extensive optimal renovation actions.
Addressing these challenges, the Plural project brought together different stakeholders to work on a common goal: to develop fully prefabricated facade modules coupling renewable energy sources and indoor air quality units with advanced insulation and window technologies to deliver plug-and-use adaptable lightweight systems for deep renovation. Plural is a competitive project supported by the European Commission. The project started in October 2020 with a duration of 48 months, a budget of 9.6 million euros, and 18 partners from 7 European countries working closely together.
Current renovation processes are time-consuming, expensive, and unattractive to building owners due to disturbance. There is a need for lowering the time and cost requirements, which can be achieved via off-site prefabrication. Plural project combined design and manufacturing of optimized plug-and-use kits and IT tools that consist of a building information modeling-based platform, LISIS, and a multi-objective decision support tool, Modest.
In the Plural project, we developed a new approach to renovating facades. It's a complete solution for a ventilated facade where new functionalities are added, easy to adapt in all buildings, reducing the installation speed, cost, and building consumption. The added benefits are that it gives users more selection options regarding insulation thickness, glass, protection against sun and noise, and air renewal. On the other hand, it also allows to create a new architectural design.
Our institute came up with an idea of external wall heating, which is prefabricated facade module. The added value of this technology is especially for existing buildings which have radiators inside and should be thermally insulated. Like this, the building can get a new thermal insulation with added heating layer, which then through old facade is heating the building from outside. It is very beneficial especially for buildings that change to a non-fossil heat distribution. Together with this new facade module and the heating layer, you can also add new windows, decentralized ventilation units with heat exchange, or PV modules mounted.
Smart Wall is a flexible prefabricated panel, eco-friendly and tailor-made to the needs of each building, combining a range of technologies such as novel insulation materials, smart windows and blinds, a variety of HVAC systems, ventilation units with photovoltaic panels, and a series of automation systems allowing its control either locally or remotely. Its added value to the Plural project is its capability to be installed either internally or externally to the building with significantly less installation time than the traditional construction methods, less disturbance to the occupants of the building, reduced waste and CO2 emissions, providing to the habitants the benefits of a deep renovation at a lower cost and time.
We want to offer the occupants to live in healthy conditions and fresh air under the lowest operational cost as possible. We are coming from the academic environment, but one day even the academics have to meet professionals in the field, and the comparison of perspective from engineers and designers might be very different. It was really challenging to understand how to transfer the technology developed within Plural project to the practice, to the real market.
The Plural concept is integrated at 3 different real demo building sites, located in Greece, Spain, and the Czech Republic, demonstrating the versatility and robustness of the overall concept, featuring different climate conditions, heating or cooling needs, and user requirements. Additionally, Plural includes 3 virtual building demos in Switzerland, Germany, and Sweden for simulating and validating the performance and operation of the solutions under further conditions. Let's learn more about Cassava demo site directly from the mayor.
Díky projektu Plural, v rámci něhož jsme nabídli tzv. Demo dům, menší objekt se 2 bytovými jednotkami, jsme získali komplexní systém zahrnující zateplení, vytápění, rekuperaci vzduchu a ohřev teplé vody pomocí fotovoltaických panelů. Po kompletní renovaci budovy, včetně interiéru, získají nájemníci komfortní a moderní bydlení. Celý systém se postará o příjemné vnitřní klima zcela automaticky. Nejen z hlediska vytápění, ale díky rekuperačním jednotkám, které zajistí čerstvý vzduch. Tento systém přispěje k vyšší hygienické úrovni bydlení. Očekáváme rovněž snížení energetických nákladů na provoz celé budovy, což se pozitivně promítne do rozpočtu nájemníků.
The project has successfully manufactured and installed in 3 demonstration buildings 3 types of prefabricated facades with renewable energy sources and demonstrated that renovation with the Plural facade systems can achieve net zero energy performance of the renovated buildings. At the same time, considerable savings were achieved in installation times and costs. However, there are still barriers and challenges that must be overcome before the broad market uptake and complete industrialization of this type of system.
For more information, visit Plural website and follow the project's latest news on all social platforms.
So, thank you for watching and thank you, Phoenix, for producing the video. Now, I think it's time for Mr. Chudis. So, good.
Good afternoon, everybody. My name is Konstantinos Tsoutis. I'm the Managing Director of Advanced Management Solutions, a company which is heavily involved in the research projects in the European Union, mainly focusing on developing products and developing technologies and processes aiming to the energy efficiency of the buildings. I would like to add some more figures of what Mrs. Foodie presented before. And I would like to say that the 85% of the building stock, over 220 million building units, were built before 2001, while the 40% of the stock was built before 1960. Each year, 800,000 of social homes need renovation, requiring estimation is approximately 57 billion of euros of additional funding per year. Almost 75% of the buildings are energy inefficient. The buildings, as said Mrs. Foodie before, are responsible for the 40% of the total energy consumption and for the 36% of the energy-related greenhouse gas emissions. The yearly average rate of renovation is 0.2%, and the construction demolition waste in 2020 was approximately the 37.1% of the local total waste. The problem that we face, and we try to find out a solution. And so inefficient buildings are often synonymous with the energy poverty and the social problems. 40 million of Europeans are unable to afford to heat their homes properly, and this is a figure that came out in 2023. People that living in inefficient buildings are more exposed to cold spells, heat waves, and other impacts of climate change. Inadequate comfort and sanitary conditions in housing and work environments, such as indoor temperatures, are deficient air quality, and exposed to harmful chemicals and materials contribute to lower productivity, health problems, and higher mortality and morbidity. Europeans are unable to keep their homes adequately warm. 6.9% in 2021, 9.3% in 2022, 10.6% in 2023. Why we select to find out a solution on this kind of the approach? Because the prefabricated construction is growing in demand over the conventional construction. Not really in Greece, but in Europe is a trend that needs to be examined and needs to be forward and monitored in Greece to be achieved. The structure is designed in a custom-made way. That means that it's a tailor-made. The pre-designed structure is developed off-site in specialized factories, and the process reduces space requirements and labor costs as well as increases the overall timeline and the disturbance of the occupants. What is Smart Wall? Smart Wall is a prefabricated facade for renovation of the buildings. It combines multiple scopes into one unit. It improves the energy efficiency of the buildings, and it reduces construction site duration and disturbance of the occupants in comparison with the traditional way of retrofitting. This Smart Wall, as we think about it and as we developed it, can achieve different size and level of industrialization, including a combination of a lot of materials. First of all, thermal and acoustic installation with a wide range of materials. We can use sustainable materials, manufactured made by recycled contents, steel frames, recycled insulation materials such as cork wool or rock wool. We combined also an air ducting system to integrate it to the facade with a central mechanical ventilation. Windows and balcony doors according to the needs of each facade that needs to be renovated. Renewable energy technologies, photovoltaic technology integrated in the facade creates this smart wall system as autonomous and energetically autonomous. The heating and cooling air conditioning system, and not only, we can use also air ducting, we can use also piping, we can use also radiators, depending on the needs of the building, each building. And also we have improved and we have achieved a very wide range of automation that contribute to the energy efficiency, like sensors or actuators to control the heating and cooling and the ventilation, and the unique system of fire protection system in the actual facade. That creates the smart wall system as an active fire protective element, which does not exist anywhere in Europe. First of all, Smart Wall is a custom-made solution. That means that we have to examine the design, we have to examine the building, we have to produce Smart Wall according to the detail that will be provided by the civil engineer, the architect, the mechanical engineer, or the certified technicians. And that allows us to minimize the design errors, to extract exactly the quantities that we need to be ordered and to need to be manufactured, and of course to minimize the waste of materials that will be generated also in manufacturing and installation. All the development of Smart Wall is prefabricated off-site in under control environment. That means that it's developed in our factory or in the factory of somebody else that is developing it for us. And of course, the main advantage is that there is fast in construction and the delivery time in order to produce it is better than the traditional construction methods. That we have to add also that minimum errors, delays, and reworks are required, and there is a minimum danger for the workers because, first of all, they work in an environment that is controlled health and safety under strict conditions. Additionally, the waste of materials are generating in the manufacturing process are more streamlined and precise than the materials used in the traditional methods and construction. But it's also fast in installation. It's installed upon its delivery. It can be installed approximately 80% in less time than the traditional construction, saving labor time and costs, with a significantly decreasing downtime. Resources are freed up with this way, accelerates the schedule of works, minimizes site impacts during the installation, and only minimum construction activities are completed on site. For example, the anchoring system needs to be built on site, or any other system that needs to be hung up with a small wall. But theory is nice, but before testing it and before proving that this works, it's useless to say anything else. So in Plural Project, what we did? First of all, we did a mechanical performance analysis. We have created a full-scale prototype, which it was anchored on a brick masonry, and we tested it in the NTUA's laboratories under different seismic conditions to prove their seismic capability. The results that I will show you later on a video which showing exactly the results of the simulation of an earthquake in Kefalonia, simulation of an earthquake in Kefalonia in 1990 of 6.7 Richters. On that test and that experiment that we did, there was no damage. There was also improvement of the seismic behavior of the masonry wall that it was hung up, and obviously it was passed according to the Eurocode 3 and the NOC 2012. We also did fire performance analysis. We tested it in the reaction of fire, and we test two types of smart wall, one with blank system and one with a fan coil and a battery. Both types of smart wall were classified as B, S1, and D0. We checked the building physics with the thermal bridges analysis to identify where are the gaps on the design and how we can improve it. And obviously, we checked it, we created a prototype. I will also show you later on the NTUA pilot building, the living lab, and in order to measure on situ a range of values like the U value, the thermography, the G value of the smart windows, the thermal behavior of smart wall, the optimization of PV placement, and the calculation of theoretical thermal bridges. Γιάννη, δεν ξεκινάει. This is the simulation of the earthquake in Bologna in 1990. You can see the behavior of smart wall. As you can see, it was completely impacted. It was no damages, it has nothing, and we were very satisfied with the result that they occurred. This prototype that I was mentioning before, that has been developed and has been installed in the Living Lab prototype, it was the first actual experiment on how smart wall can be installed on a building, and we were very pleased and satisfied with the results that we achieved. You can see the previous state of the Living Lab as it was before and the installation of the smart wall. We removed the existing wall of the existing lab. We unload from the crane the smart wall. We unpacked it. We lift it on the position. We secure it in its position, and it has been completed. The overall duration, amazingly, was 12 minutes. From the time that it was unpacked till the time that it was completed, it was only 12 minutes. And we were very happy because that proves the way and how fast can be a smart wall to be installed on a building site. Now, what we did in Vula, on the Greek demo site of Plural, the Greek demo site was a little bit restrictive because we could not alter the facades. We cannot change the facades. It's an historical landmark, so that means that we had to replicate the exact facades as it was before the renovation. We started with some preliminary works, which means that we had to take off some old shutters, we had to repair the walls on the rendering, we had to repair the existing services that they were deteriorated, and we have to remove it. And also we have to do, as I said, the local repairs on the walls, and then we have to lift and unlift the components of the smart wall. Then we start working on the auxiliary installations. First of all, the heating and cooling system, which was including pipework, wiring, and heating pumps. And we did some ETICS installation on the east facade of the building, and it was mandatory because we could not actually touch the east facade due to the services ducts and the services that they were passing through it. And this was a request of the technical department of the municipality of Bula. And we start working on the actual installation of smart wall. First of all, we installed the anchoring system on the exterior side of the building, on the exterior elements of the smart wall that they were installed on the building. And then on the interior. The system might be the same, but it's not the same. They have some differences among the system that we were using, because the brick wall condition was different, and we have to examine the way that it will be installed. We changed all the balcony and windows installation, and then the smart wall started to be installed. First of all, a layer of insulation has been used in order to reduce any gap performance that they might exist between the existing smart wall and the actual wall. And smart wall was installed by 2 workers. Each unit needed about 30 to 35 minutes to be installed and secured on site. Similarly, we did exactly the same thing for the interior side. As you saw today, you can see no difference between the existing walls and the walls that the smart wall has been fitted. Also, very quickly, with approximately 35 to 1 hour in order to be installed internally. And then we did all the finishing works. We have to treat the joints that they occur between the panels. We have to do the skirting installation in order to protect the moisture and damp. We have to do some local repairs because of the transportation, and the installation in areas was damaged. And obviously we need to repaint all these areas that they were damaged and patch them wherever it was necessary. All this smart wall is controlled electronically, digitally, and all the data that we achieve, and we achieve data from the internal air quality as well as the energy meters of each system that is installed, is also uploaded in our platform, HAMS, and the license platform of the Plural project. Now you can see how the building was before the installation of smart wall, and how it was after the installation of smart wall. Similarly to the exterior of the building, some pictures, obviously you saw also some in the video, and the interior of the building. And I think that's it. Thank you. Any questions?
Thank you very much. It is very interesting and very promising, and I hope we will have the opportunity to continue the development and collaboration. The next presentation will be made by Jaume Colom, who is the owner of Denvelops. Denvelops is an innovative company that produces facades in Spain, in the area of Barcelona. And Jaume is going to present the Denvelops comfort wall.
Four? Okay. PDF. Now I put highlight. Sorry, I'm trying to make full screen, but maybe here. Oh, yes. Thank you. Well, thank you all for being here. My name is Jaume Colom. As Maria said, I'm from Spain. I'm architect. I am the founder of Denvelops, the company Denvelops. And now for the Plural project, we call the evolution we have made from the original system, Denvelops Comfort. And yeah, I would like to call this presentation like adding functions to the new architectural hybrid textiles, from a sunscreen to ventilate facade case. And this is because when we started years ago, we're a young company, we started developing something that we call hybrid textile, and it's more focused on doing sunscreens. Then due to the Plural project and the EU call, we found a great opportunity to improve our solution to achievement to do ventilated facades, in that case NZEP, and we thought it was a really good opportunity to do that. So first, I think that to understand what we have done, it's very important to know what was the origin, because in fact this is what I'm telling you, it's an evolution. So an architectural hybrid textile is it's a new system that can be rigid or recently even flexible, made with cables. And it mostly is useful, very useful or very appreciated to do sunscreens, pergolas, walls and ceilings. I mean, you can do beautiful sunscreens with beautiful shadows, even pergolas. And it can also be installed interior in front of walls and on ceilings, maybe most in a decorative way. The system, what you will see later, allows to put the tiles. It's a cladding system, that can allows you to put the tiles in a kinetic movement, so which means that the wind moves the tiles and create very beautiful effects. And also can be static, like you control the shading position of each tile, trying to, in relation what you need. Maybe you want to have more shadow, then you put the tiles in horizontal, or you can have it like in more vertical to create like private spaces and improve the sunscreen. And I will also of course, add that the system is fully 100% very strong. It's precisely manufactured and very quickly styled, which means that in fact it was already thought under the lean construction manufacturing system or philosophy, something that is right now very well appreciated in the construction, because all the lean manufacturing talks about reduction of waste materials, optimization of the manufacturing, optimization of the materials, etc. So going a little bit inside this system. The system is just made with 3 components. I don't know if we have, well, number 1, this is the... we don't have today the mark? Okay. Well, number 1, I'm sorry. Yeah, they're asking me to speak higher, sorry. Now, number 1 is the vertical lines, our vertical profiles are always done by stainless steel, and it's cut by CNC machine, a laser, which means that you can always choose the free modulation and the shape of this component. The second one is a connector, is a spiral ring, which also is done with CNC machines, and you can always change the lengths or the designs to be able to install a lot of tiles of different tiles. And the 3 one is just the tile, is the covering, the cladding system. Just say that modifying these 3 components, it gives you a big game to do a lot of customized solutions. So it's very adaptable. Then the installation systems for outdoors, we can work with very large format scales, because we can just do in frames of 3 meters long. We can link it by small hinges, and you can achieve like lengths of, I don't know, 50 meters height, whatever. And the weights also can be as much as you want. Maybe the limit is the weight of a truck to have an optimized transport with the trucks. The system, you can make like frames, you can also install in a small frames for interior, so there is always a solution to find out for the best, for the requirements of each building. About the pieces, as you can see in this image, we can just install a lot of pieces and materials. And right now, due to the Plural project, I would like to explain that we work a lot trying to find a fast system to install the tiles, because as you will see later, our solutions consist on pre-install the systems in hybrid textile and then finish installation on site. Which means that now, due to this evolution, we are now able to install not only metal plates, the one that we have used in Plural. Right now, we have made agreements with other companies, and now we can install like bricks, or wood, or a lot of different materials. Then talking about design, as I was explaining you, as the system is all cut and done by CNC machines, it's very easy to adapt the design to any modulation or requirement. And even as it is done by small components, it's like a parameterized system. We have developed a plugin which helps to do the designs for the facades, which means that in case you want to do more sophisticated drawings or communicate more aesthetical things, it is easy and fast, and that's very interesting because it takes off a lot of hours of designing for the architectural firms or the designers. Of course, just commend you that in our company we have a potent technical office, so in case you want to work with this type of solutions, or now with the Plural comfort envelopes that we have developed, I mean, we give all these services, so there's going to be no problem. And then also explain that, well, we already started to work with ETEC, certifying this system, and now with the Plural project, we also have been working to ETEC to preview how we can extend the certification process for the new system. So we have the guarantee that everything has been certified, everything has been studied, and all the Plural team, and also before from ETEC. So it's a reliable system, it's safety, and there's no problem. Like sometimes we talk about, people think about innovation and something, oh, I don't want to test it because it's the first time, maybe another have to do it, but it's not this case. Then some examples of possible applications or works you can do with the system before using the envelopes comfort. And when you see, like, we can do like pergolas, we can do like facades. I don't know. This time also is interesting. The potential to make the facades with marketing finishes. No, like you can communicate more than just a facade. No, from length. So far you have a nice aesthetics, but then when you come closer, there can appear another level of communication, no? Which is also interesting. Another more examples of the different finishes that can have this system. And these are examples of some projects we have done until now. Maybe here stands up also the possibility we have to insert lighting on the system, which means that sometimes in some projects can be interesting to add light. So you can have in night a very fancy project, and during the day you can have a white facade, very potent. Also, this new pergola we have developed in flexible system. This is this image. Sorry. Which is very interesting because this pergola, the tiles can rotate. So when the wind is higher, it starts to rotate. So it don't take much wind lowers. So it's a very optimized way to have good shadows and the less possible structure. Also, as it is a cladding solution, it allows you to see the facades of the streets while you are having the shadow. So now that I've explained a little bit how is our system, when we were invited to participate in the Plural project, we really thought that it was a really interesting opportunity, no? Because we were just doing only like sunscreen, no? And somehow you're always talking that you can also do a ventilated facade, but we have never tested and we have never resolved it, no? So this was a great chance to this project to make this improvement to our system, no? And the main point was, of course, trying to preserve as the maximum the characteristics of the envelopes, no? What is interesting from them, which is very light solution. The envelopes normally is about 15 kilos a square meter when you're using metallic tiles. If you use ceramics, maybe it goes to 20, 25 kilos per square meter, so it's a very light solution. It's very adaptable, so that new envelopes comfort also have to be very adaptable, and it is. And it is a system that highlights for its fastest speed installation and very economic cost. Economic because the weight of the components are very few, are the less. Everything is assembly with no weldings, just by small screws or by elastic connections. And the installation, as you can work with very large formats, it's very fast, so it is really competitive. So for this multifunctional facade that Plural was what we agreed to do in Plural, no? In our case, we we decided to do a solution that should include windows. Number two, air renovation, unit ventilation made by Cebut, and windows made by BGTech, and insulation, thermal and acoustic layer. We also should include photovoltaic energy, and we also include louvers. No? You can see here the mock-up, no? And where are these elements cited. And yeah, this solution should achieve with NZEP energy consumption, which we did. We should be competitive with cost and fast installation, which I think that we also have accomplished it. It must be an off-site solution, exportable. It is, as I explained. We can produce this in very small components, and in terms of exporting or trying to, because we're in Spain, we are doing some project in where we are sending all the components just alone, and you can assemble in some store and some place close to the job. You can assemble there and fast install there, so that you can even reduce the cost on the transport, which is maybe one of the big barriers of the precast systems. The fact that transport big surfaces, sometimes it is too expensive. But there's no problem because as I said, we can just produce on site. It's a scalable solution. Yeah, well, our system is just about linking frames and making very large format installation scales. It's lean construction, as I explained you before. It's clear and friendly and green materials. Well, see, there's no welding. It's all assembly with the screws. Stainless is a very large material with no maintenance. And the tiles we can put. I mean, we can choose any materials like no ceramics or wood, and that are very sustainable. So. The strategy to achieve this solution, no, for us was, well, since we have a light system, which is very light and thin, but have dilatations when we install it, no, because it's a system that is hanged from the top, and then every slab you put a wind retention anchor. What we thought is like to do, okay, we want to do this plug and use system. We want to hang it, and when it's hanged, by developing this resistible system, the tiles I show you that you can easily put and take out, you will have this already hung it. You don't have to go inside of the building. You just go there, you hang, and you finish installation when the facade is hung. So which means that the disturbance on the neighbors are the less, because once you have hung it, there are two workers outside that they are finishing every installation step without being inside of the house. And for that, we develop what we call like a temporal anchors. No? For example, here in this first system image, I show you in red. This is a temporal anchor. It's like we have the windows in the frame, and once we are in the building and we have hung it, one worker arrive there, open the louvers, and just push the window to the side, and they fix it. And remove the temporal anchors, and the window is installed. For the air renovation system, the unit ventilation, we did the same strategy. We also put some temporal anchors, which we hung it, and then once the unit was in front of the place, we just push it to the wall, and we connect it to inside, and that's it. And this for us maybe it's very important, no? Because we demonstrate with this solution, no? In the plural we have tested many technologies, and we were asked to integrate this technology within our system, and this demonstrates that we can have an active system and that we can achieve design ZEP consumption. Actually, this unit ventilation, I have to tell that is working very well, that the users are really happy. They are having fresh air, and that the machine, as a first test that we are doing, is working very well. So I invite you to buy it. So. And then for the insulation layer, we also develop a temporal anchor. Well, in this case, maybe it's not temporal anchor because it will remain on the facade, but it's like a knife that allows you to push the insulation. And once you have in front of the facade, you push insulation, you install it as normal, which is just a few screws, and then this knife keeps on the side to pressure the insulation to the wall, to improve the insulation of the whole system, no? And to create the ventilate chamber from the tiles to the insulation to have a real ventilated facade. Sorry. Then the two other functions we had, it was the lowers. Lowers bus is very interesting because we are, one of our strategy we think it's very interesting is to keep the old window and to add a new layer in order to don't have waste, in order to do not make disturbances to the users. But sometimes, well, it says that when it's summer, it's hot, these two windows can create can improve a little bit the heating, so that with the louvers you can protect this area and keep the balance cold in that cases. Also for the PV tiles, it was just, the system, as you see, all the vertical lines are with the laser cutted, so it's really easy for us to add holes where are required to install any type of tile. In this case, the architectural one, the designer of the solution, Big Architects, made this proposal of design using these tiles of 40 centimeters by 120 meters, and we just bought from a provider, and we install it easy, fast, and we took to with the system within install, and then once we hang it, we just finish the connection to the electrical system. Well, maybe, but now it's like the envelopes of why, no why? Well, so it's a small cladding, sunscreen, and facade expertise. I mean, we are maybe, we can afford something interesting when if you are trying to search something with a small cladding facade, something that can like connect from a sunscreen to a ventilated facade, all this type of aesthetics is where we can give much value to you, no? To make like big formats with no small tiling designs, this is not our target. This is a light solution, as I explained you. This is CNC produced, which means that CNC is really interested and connected to the digital design, no? As Constantino explained before, our requirement is also to start the design is very important to have a good elevation and digital design from the building in where we have to work. And from that, we just draw any modulation. We just can make this modulation with no extra cost. Sometimes change modulations in traditional systems is very expensive, no? Because bricks, for example, are made in a large change factories that is difficult to make the changes, but this is not our case. Then the system you've seen is the basement is, and the aim is a stainless structure, which means no maintenance, a very large duration, easy to recuperate. It can be installed in very large formats. It according every project, we just can choose the size of the strategy to improve the installation, and there are many possibilities. So there is always one strategy that will fit on your requirements. It's weight reduction, of course, due to the lean construction. It's now 100% tile registrable, so it's very interesting in case you need to access to the interior, to do maintenance operations, to check anything, to, I don't know, put new cables for somehow. This is very interesting. It's fast construction and delivered, well as of course as traditional construction methods. As much technology we are asking for a facade, it's much interesting to have it done off-site. And as I explained you, the system is dry assembled with no welding. It's very fast to do. So once we have the project defined, normally between 2 or 3 months we can send the fabrication to anywhere. We have a technical support, a technical office in a system which is certified. No? I mean, this is new, we know, but it's 100% fully certified, so we will have no problem about achieve any normative requirements. And it's a safety innovation, because at least we are not doing like something very new. What we are trying to do is do the same things in a different way, no? But at least you can imagine the system as a very tall railing, no? Everybody knows how to install a railing, so there are metallic anchors, is things that everybody knows how to calculate. So from this point of view, there's no risk on using this new technology. Now, about what we did in the project, no? Of course, we did a first mock-up, and we test, no? The initial drawings and the initial strategies we prepare. Here, some images of the large work we did. We took a lot of empathy. I don't know. We were really over about the ventilation unit in terms of we know that these machines, when are installed on a facade or close to the people, sometimes can make noises, and we did a large study. We did some tests, and we can just say with a lot of pride that the units are installed and there is no noise, and the people is using it very happy. So that's a great achievement. And then here you see some images of the ventilation knife. Well, here the first, in fact, this prototype, this first lowers, and after we change it, and you can see also the back of the mock-up and the first installation of the window, which in this case also was hung in this moment with the temporal anchors. But it works, no? We were really happy. Then we came with the real project. It's a project, very ambitious project. I mean, at least is big project for me. It's 200 square meters. To achieve the modulation of the facade, we had we work with 7 modulations, no, to arrive to all the separations between each window. The architectural firm asked for 5 colors, so which means we had 35 tiles, references. And in total, here there is an amount of 4,500 tiles installed in 21 sequences. You can see the AU, AU2, all the sequences we installed. There were like 50 photovoltaic tiles installed, all of them, everything went perfect. 6 unit installation that we installed here in the first floor, and that were used after to take all the data and to check that the system really works and that we were achieving all the NZEP made by the people from Iraq. And then we also installed 18 windows and louvers, and 18 louvers. That is 170 square meters of insulation, 344 insulation knife, and the weight per square meter it's about 34 kilograms. This is numbers are so accurate because everything is like digital design, no? So which means that using these systems, when we said this will have this cost, is this cost. And once now we have also the experience of the installation, we also know how many time takes. So in terms of feasibility about the budgets we do, we have to say that are really reliable and that there are no frozen costs. Well, here's some image of the production and just the installation. We must say that, well, I would not say that everything went perfect, but I would like to here do the prediction, no, that what we think that next project will be. No? We think that for these 200 meters, we took 40 days with 4 workers, which is 2 months. And then for the installation time, we took we should take 12, I put from 12 to 10 days, Lincoln and Hangil, because when we did the project, we had a lot of, we have some delays because the workers were not trained. We also had very bad weather, so it seems like everything went against. But the last day of the installations, we did very good marks by installing three sequences per day. And so it was an expected installation time we preview at the beginning. And the cost by a square meter is from 450 euros up to 70. Of course, every project has his own small things, so it can change. And so now I explain you my final considerations. Just say that if somebody is interested on using this technology, just the sunscreens or this ventilated facade solution, you can easily ask to ask. Now we have done all the job. It's easy for us to make budget, to do technical studies, so there's no problem on that. The other consideration is that if, of course, you want to work with off-site constructions, the best profit you take is when you, as more functional systems, you try to use. I think that our result has been is a very beautiful architectural result. I mean, from the point of the architecture to the fancy solutions and to things that can be easy integrated anywhere. This is a good solution for that. This is a solution that takes the envelope comfort have the same aim of the sunscreen, which means that you can easy merge, like doing a beautiful sunscreen that then becomes a ventilated facade that then can also again becomes to sunscreen even for a pergola. So you can think about doing like a whole dress like for a building with this system in a fast renovation image for some buildings. It's very adaptable, as I explained you, because it's digital and it's easy, produce it with CNC and laser, etc. And we can even, well, I put this sentence, use bigger tiles to reduce costs. It's also important to comment that many times when we're trying to do a project, just changing the size of the tiles, the cost change a lot also, which means that there is always a solution that fits the design of the requirements of the design and fits to the budget of the customers, which is something that it's like difficult to achieve. It's resistible, and the system, the system as you see is very simple. So the maintenance is also very, very few. Just to finish, I don't speak more. I will put you a small video that Agencia de l'Habitatge, the owners of the building, made from all the installation process, and that's it. This is the building how it was. Well, thank you.
Thank you, Jaume, for the very, very detailed presentation. For the Greeks, it may be a little bit futuristic, the outcome for our standards, but I tell you, it's really beautiful when you see it in Terrassa. So the last presentation will be done by Daniel Filippi from SPF, from the Eastern Switzerland University of Applied Sciences, and he will present the third system, which we call our college wall, the technical characteristics and how it was demonstrated.
Hello from my side. Thank you, Maria, for the introduction. Yeah, so the challenge I can keep short, we have already heard about. We need an energy transition for the buildings all over Europe. We now come a bit more to the north. It's might be more snow in the region where the Konix wall is used. And yeah, well, the challenges are we have to do a fuel switch from fossil fuels to heat pumps, which then should be use electricity from renewable energy productions. And the second problem is we have high energy demands of the buildings, so heating demands. And in these both topics, the Konix wall tries to give a new solution to have a better building stock. So you already saw this in the movies before. So what we are doing with the Konix wall is we bring a prefabricated facade with a crane to the building, and yeah, you saw this already. In the end, we have from outside it looks as really a new building with PV on the roof, so solar energy is used and produces electricity. and the whole facade is deeply renovated with a much better U value, so a lot reduced heat losses of the building. As said already, this was done in Czech Republic, in Kašava, a small village in the east. And so the before and after status is quite here. It's very impressive for this building. So we started with an energy certificate of G, and now we have a building with energy certificate of A, which is a huge development or increase of quality of this building. So what are the features of the Konix wall? As I explained, it's a prefabricated facade element. The abbreviation stands for conductive external wall. That should explain a bit the functionality. We bring heat via conductive contact via the external wall of the building, the facade, to the rooms. Here on the picture you see the main functionalities or features of the Konix wall. First of all, we have a heating layer, so water-filled pipes where from the heat pump comes the heat and then the heat comes to the old facade and then diffuses through the old facade to the rooms inside the building. So we heat the building afterwards through the old facade. Second function is, for sure, we need a better thermal insulation, so we also add a new thermal insulation. Then we have with 3 a ventilation unit, decentralized installed, because maybe you know if you have a new envelope of the building after refurbishment, often you have within the building the problem of humidity, and this humidity should get out, and also with a ventilation unit you had a better indoor air quality for the users inside, for the tenants. What is missing here, I don't know why exactly. So we also bring the new windows. So the windows on the picture is brought as well, or can be installed into the new facade element. And after installation of this facade element from inside, the old windows can be dismantled. So we also bring new windows, which are included in these facade elements. And you have also the possibility to add PV, facade PV on these panels, or also solar thermal collectors. So the main application of the Konix wall would be, in our view, larger buildings, maybe with 8 apartments or more. Here on the picture you can see the virtual demo in Sweden, Maria showed before already. It's in Väsby, and there we took one of these buildings as a typical application for the Konix wall. Why this is of interest, or why this is important, we need more or less uniformly buildings, so rectangular walls, and by this it's easy to add these prefabricated facade panels to the building. And also an advantage is, you can see this here with these red rectangulars. If you have designed for one story, the one panel, you can multiply this for the stories above. So you gain a lot of, or the design of one story you can use for all the other stories. So you reduce the design cost and money in this way. Another, as I said, we heat through the old walls, so the old facade, so the U value of the old facade should be quite bad, so it should be 0.9 or above, so that the Konix wall is able to bring the heat through the facade to the rooms. There are also 2 other important things. The heating, so the Konix wall aims to bring a solution for buildings where you want to have to switch from fossil based heating system with radiators to heat pumps plus surface heating. And another point is, or an advantage is, the tenants could stay inside the building during renovation. And this is the 2 last points are exactly where the core view of this Konix wall, or the biggest advantages, are valid then. So back to Kašava and Czech Republic. On the left you see the building. Again, the southern facade. On the right side you see, just to show what we did exactly, so we brought per room, we have heating loops. You might know the heating loops per room from floor heatings, and so we took the kind of floor heatings just to the facade. Installed were 8 facade panels in these in the Cassava demo. 14 heated rooms are supported now by the Connex wall, and in total we have 27 heating loops. So just to show how these facade panels are produced by the company RDR, a partner of Plural project in Czech Republic. It was, as I said, kind of a floor heating system which was used, but then brought or installed, prefabricated, or pre-mounted on these facade panels in the company. And then on site with the crane, these panels were installed. This took only a few days. So after a few days, these panels, the whole building was had a new facade layer around. Here on the right side, you can see how this heating layer then is attached to the old wall. This is a view of the installation of the roof panels. So some walls were installed as well, and then the roof itself. And yeah, finally, a refurbished building. As you can imagine, it's a bit of a challenge, or it's a new approach to heat a building from outside through the old wall. So one key issue or view was on the project to check whether we can reach a good thermal comfort for the inhabitants. Here on the picture you see, as an example, one room. It's a sleeping room in the building. And each dot here you can see is via simulation the temperature in the room. So each dot represents 1 hour of a year. The colors are the different seasons. And for Cassava, very important is the blue cloud, let's say, of dots. It's during winter time. So via simulation we could show that we keep the comfort in the building during the winter time. Why do I say simulations? We ended this renovation, the Plural project, very late because we had some delays. So we had no first winter with real measurement data, which is a bit of a pity. But we use validated simulation. We did first tests of the heating system, and now we're on the safe side. We think that we can say with simulation we can show that the effects are good in winter time. In summer, you see that the red dots over there. You see that we are, well, I forgot to say, you have a comfortable situation if these dots are within the black boundaries, which are shown. Also relative humidity is shown. For summertime, you see that the red dots are sometimes outside. In the project, we didn't focus on summer because Czech Republic is quite in the north. But we try to, in maybe next developments, we try also to look at the summer, and it's possible definitely to also cool the building with a Connex wall, but there was no focus on that in the project. Yeah, maybe more statistically with a predicted mean vote, which is also a very general view whether inhabitants will be happy regarding comfort in the building. It's mainly the same to show here. If these values are between 0.5 minus or plus, we have a very comfortable situation. And again, here we see just in summertime we have for the different rooms shown here in the graphic. We might have an issue of heating for overheating, but the important view here is the winter, and here we have a comfortable situation for the inhabitants. I already want to summarize what are the advantages of the Connex wall, or show you the advantages for the Connex wall from the view of the building owner and from the view of the residents. So the Connex wall, like many of the prefabricated solutions, gives you a faster renovation time, a shorter renovation time, and by this possibly also greater acceptance. What we also bring with the package of the Connex wall is a good view on or a control of the building physics. I already mentioned this topic of humidity in the building is a problem often after a good renovation of the buildings. And so you need a ventilation, and this is included in the system. And we have decentralized ventilation per room, which brings, on the one hand, good comfort for the inhabitants regarding CO2, but also humidity is handled. Then another topic is after the renovation with the Connex wall, you have a very high building standard, which is also helps you keeping the energy costs low and also to be within possible regulatory compliances of future. So you have like a new built building regarding energy performance. Advantages for residents, you have a minimal disturbance due to a fast renovation. And this might be also a very important issue, so the tenants don't have to move out the building during refurbishment. And for sure you have an increased comfort, thermal insulation and ventilation are giving you this as a tenant. And after the renovation you have also lower energy costs because of a new insulated facade. This is from my side, very short, an overview on the Connex wall. Thank you for your attention.
Thank you, Daniel. Comprehensive presentation that covered all the important aspects. We are gradually coming to the close of our event. Before concluding, we would like your attention for another 10-15 minutes. In the frame of the project, we developed some training material and handbooks that can be used by architects, designers, constructors, all the people that are involved in this process, and we would like to present to you where you can find this type of information if you're interested and if you want to follow up what we have done. The presentation will be done by Anna Takova from Phoenix. Phoenix is our partner that developed also the video that you saw before and has been covering all the dissemination aspects of the project for the 4 years duration.
Thank you, Maria, for the introduction. Good afternoon, everyone. It's my pleasure to introduce you and guide you through the training activities of the PLUR project. So the PLUR project is designed to empower professionals in the constructions and renovation industry with targeted training. Our goal is to make plug-and-use kits renovation accessible and effective through an easy accessible e-platform, which you can scan through the QR code on the screen. It is linked to the Plural official website, which supports training for all stakeholders. On the e-platform, you can find training workshops, demonstration videos, and also success stories handbooks that were created at the end of the project. The online training course is structured into detailed modules tailored to professionals working on nearly zero energy building renovation. It addresses key challenges in sustainable retrofitting, providing innovative tools, strategies, and techniques. The participants can gain knowledge in enhancing building performance, minimizing environmental impact, and how to improve the occupant comfort. The online training course is structured into 6 chapters, all covering all the aspects and steps of the PROL project. The first chapter, you can learn there about the PNU kits development, explore the system, the modularity for sustainable retrofitting solutions. You can also learn about the PLUR concept itself and the project's vision. The next thing you can learn is, of course, the consortium that has been working for years on this project and the individual partners. In the second chapter, we have summarized all our solutions and the plug-and-use kits, including the Smart Wall, Connex Wall, and also the Envelopes Comfort. In the chapter 3, we have our demonstration sites that my colleagues have presented about. So from the Czech Republic, Kašava, Greece, Vula, and also the Spain, Terrassa. Here you can also learn about the technologies and the solutions that were applied and implemented into those demonstrations. For the chapter 4, we have included the testing. One of the testings videos you have just seen in my colleague's presentation, which was the seismic table tests. We also did a fire testing and facade testing. All of those videos are in our e-learning course. In chapter 5, we have included our interviews with our partners on the digital tools. There's first an introduction that provides the overview of the analytics and decision support platforms. Two of those are the Smart Energy System and also the MODES platform. For our last chapter is the handbooks, as I mentioned. With the efforts of the whole consortium and the partners, we have created 3 handbooks to support further the training workshops and the solutions as well. Here you can see all 3, so Industrialization Best Practice Handbook, the best practices on LCA, LCC and social assessment, and the best practice on certification and innovation solutions. In the first handbook, you can learn about the optimizing quality and efficiency, and it focuses on the streamlined production and installation processes while maintaining the quality. In the second handbook, that focuses on offers insights into the environmental and economical sustainability. As I mentioned, understanding the life cycle assessment and identifying ways to reduce energy emissions and waste, and also applying the life cycle cost, LCC, to evaluate the economic impact of PNU kits. And the last handbook focuses on the guide market readiness, focusing on safety, compliance with EU standards, of course, developing environment product declaration, navigating the pre-standardization process, and the certification. All of these handbooks are available on the e-platform and also the Plur website, so you can download them there. So I encourage you to visit the whole platform. You can scan the QR code, visit it immediately, and here's also the link which you can save. Thank you very much for your attention.
Thank you, Anna. I hope you will find a couple of minutes to visit our website and download the material, the training material and the handbooks. Even if they are supportive, I'm sure that they can give you some useful information for your plans in deeper innovation. Before closing, I would like to ask whether there are any comments, observations, or questions from the audience. If not, please give a very, very warm applause to the Plural partners and the consortium that worked very hard for 4 years to achieve the results that you have just watched today. Thank you very much, everybody. Just to let you know that for 4 years, the website will remain active and you can visit and download the material.